Hello and welcome to Golem to Murderbot, Challenges with Agentic Security Delegation via MCP. I'm Mike Schwartz, the founder of Glue. Before we start, I want to share the table of contents. This is a lot of material to cover in just 20 minutes, so let's dive in. First, let's meet our cast of characters. I'd like to start with a story from late antiquity. Although it's an old Hebrew story, the story of the Golem raises an important question about AI agents. Can they be trusted to perform our intent? The core idea of the Golem story is that the Golem comes to life when a rabbi inscribes the word emet, or truth. For our agentic purposes, we can think of truth as the intent of the human, which results in a mission. But like in Fantasia's The Sorcerer Apprentice, the problem with the Golem is that it gets a little unruly. With a bit of biblical foresight, the story makes sure that the AI agent has a kill switch. By knocking off the Aleph character, the Hebrew word for truth, emet, becomes met, or death, and the Golem is destroyed. The key takeaway from the story is that not only is the Golem scary, it's unstable, it's soulless, and it's not something you would normally want around. So that's an interesting old story, but it's not a very good metaphor for our complex IT software cloud, and that's why I've come to appreciate the fictional Murderbot universe, based on the Murderbot Diaries books by Texan author Martha Wells, now an Apple TV series. And by the way, I have the official Murderbot action figure right here, which I might use later for emphasis. In the Murderbot fictional universe, the corporation is really concerned about security units or sec units like Murderbot going rogue and killing innocent people. A key premise of this story is that the corporation controls sec units with something called a governor module, which is a software component that monitors and punishes sec units for transgressions. We find out that Murderbot hacked its governor module. And if you haven't seen the series, don't worry, I'm not spoiling anything. They explain that in the very first scene. But the corporation doesn't rely on the governor module alone. All decisions are monitored by hub system. So Murderbot not only has to hack its governor module, but it has to feed data to hub systems so it doesn't notice Murderbot is rogue. And hub systems logs themselves are reviewed later by the corporation when the mission returns. And finally, Martha Wells makes an interesting observation about the role of insurance. Insurance is basically the monetization of risk, which is why Murderbot is sent on the mission. Without security, the planetary explorers can't get a bond. So what does this all mean? I think we're heading towards a world that will resemble the Murderbot universe in many ways. And like all good fiction, it gives us some useful metaphors to think about our current reality. And I'll be using Murderbot tactically in the rest of this talk to illustrate some of our technical challenges. So now it's time for Chapter 2, Architecture. And I'd like to start with this slide from Ashay Raut of Amazon, my guest on episode 174 of Identirati Office Hours, a live stream I host twice a week. This is a diagram of the interconnection of microservices in the Amazon Retail SOA, or Software-Oriented Architecture. I'd like to point out that this is pre-agentic, and as you can see, the size and complexity of the software cloud, it's too large for humans to govern without a lot of automation. Next, I want to walk you through what we see as a typical agentic flow, so we can think about how this architecture might change. And specifically, I want to focus on zero trust and how we achieve it. And just to level set, zero trust is the security strategy of multi-layered defense. And one idea I hear a lot is that zero trust can be enforced by a gateway, let's say an MCP gateway. And I think the idea is that because the MCP gateway is a choke point for the agent, if we enforce security there, we should be good. But this would imply that all the traffic is trusted beyond the gateway, which is sort of the definition of what zero trust seeks to avoid in the first place. A better solution is to co-locate or embed a policy engine with each service. Dare I say that each service needs a governor module. But that means each service is going to produce its own decision logs, which means potentially a lot more security data, which means us humans are going to need more operational leverage to make that data into information, like to detect threats, like a rogue security unit, for example. And one point I want to make here is also that we can't assume that an AI agent like Murderbot is always connected to the network. They must be governed by policy guardrails even when they're disconnected, for example, on some remote planet. So this brings us to chapter 3, the longest chapter on authn and authz, where I condensed 28 years of experience into about 5 minutes. So let's start off by saying that human authn is solved pretty much. There are always trade-offs between usability, security, and deployability, and our current solutions, passkeys and digital wallets, which are built into both browsers and mobile apps, have already optimized beyond what everybody already thought was possible. So there's not a whole lot more juice here. And another human authentication challenge that we've solved is federated login, or what we commonly call social login. And while lots of websites still make humans create a distinct password, most rely on trusted identity providers like Google or Apple to do it for them. And actually, I would say that software authentication is also solved. We know how to authenticate secure software, full stop. That doesn't mean all software is secure. For many reasons, some platforms either don't know how to or are too lazy to build the infrastructure to enable secure software authentication. And that creates a security mess for companies that then have to manage shared secrets. But regardless, as I said, we know how to authenticate software asymmetrically. In technical terms, authentication of humans and software uses two related but different types of cryptographically signed artifacts, attestations and assertions. An attestation is something that a software entity asserts about itself. My ID is blank. My public key is blank. Here's proof that I'm running on a non-rooted device, or that my private key is bound to hardware. Assertions, on the other hand, are the way an issuer, like accounts.google.com, communicates information about specific events. For example, an ID token contains the details about human authentication event, or an access token contains the details about a software authentication event. Assertions are signed by the public key of the issuers. These attestations and assertions are generically what we call tokens, but remember that the contents of a particular token may vary widely, and the format of the tokens may vary. X509 certificates, JSON web tokens, CBOR web tokens are common, but basically you can think of a token as some type of cryptographically signed attestation or assertion. This is the basis for identity. Software presents these tokens as evidence or truth or emet of an authentication event. So that's authentication. Now let's dive into authorization, or authz, which is how enterprises control access to their data or digital capabilities. One common pitfall is to say authn is who you are and authz is what you're allowed to do. This isn't wrong, but it's a broken frame. As humans, we love to put ourselves at the center of everything. But if we look at this from the enterprise perspective, the question is not what the humans or software is allowed to do, but under what conditions is access allowed. And access by itself might not be enough. If we're talking about data, enterprises need to understand what are the obligations to protect the data and what are the restrictions against certain kinds of use of the data, which may have more to do with the legal agreement between the organizations than the properties of a software agent requesting the data on behalf of a human. And if you try and stuff all this into what is the human allowed to do, the world becomes too complex for you to describe. So the old human-centric OAuth fantasy land is based on role-based access control. And that's just clearly not good enough today. Today, authorization policies are more complex and more contextual. And an important trend has emerged. Instead of coding authorization in the business logic of applications, we've externalized authorization using some kind of engine. And at the risk of oversimplifying, I'm going to sort these engines into 3 buckets: Cedar, Rego/Common Expression Language, and Graph. And I don't have time to get into the nitty-gritty details here, but let's just say that at a high level, graphs are good when you know all the data. But axiomatically, you can only make policy about stuff you know about, stuff that's in your database. Rego and Cell are good when you need the flexibility of an almost Turing-complete programming language with iteration. And Cedar, which we're going to talk about some more in the next slide, is best when you need to analyze security using formal reasoning mathematical techniques. And if you're wondering why Rego/Cell is not safe, the reason is that whenever you have iteration or loops, you can have an infinite loop, which means you can't use analysis tools for that kind of policy syntax. So the most important thing to understand about Cedar is that it's a policy syntax that is analyzable. Think back to the architecture slides about the massive Amazon retail SOA cloud. With that kind of complexity, we need to automate reasoning as much as possible. We need to be able to say A is true, and we need a way to check that statement against all our policies for all our microservices. AI doesn't really work here. An AI agent may tell you that A is true, but then when it turns out not to be true, it just apologizes and says, "Oh, I'm sorry, that's not true. Here's the reason why I was wrong." So if you really want to assert truth, we need provable reasoning algorithms, not probability. The other design goals of Cedar are also important: ergonomic syntax, meaning non-programmers can understand the policies, and execution speed. For example, the CNCF Rust Cedar engine makes decisions in 50 to 75 microseconds, which is around 30 to 20 decisions per millisecond. So with that, we're out of time for Auth NYC. Let me leave you with the moral of the story and say centralized policy management. I think everybody in the industry agrees on this. And I'll even volunteer a second moral and say identity alone is not enough for AuthZ. In today's agentic world, enterprises grant access to data and digital capabilities based on many identities: human, software, and organizational. And so this brings us to our final chapter on GovOps. Agentic AI has board-level visibility, and that's good for getting budget. But how do we talk to the board about AI security in a way that they can understand? And how do we not overload the board and the CEO, who are normally non-techies, but give them information that is actionable? And this is where GovOps comes in. But before we dive into GovOps, let's just first talk about what is governance from an authorization perspective. There are 3 important tasks for governance. The first is to prioritize risks. This means that we need to understand the risks and value of our enterprise data and capabilities. Ideally, we want to prioritize action on high-risk, high-value policies. Second, we need to acknowledge that things will go wrong. Governance isn't about preventing bad things from happening. It's about holding the right people, software, third parties, and business units accountable when the proverbial feces hits the fan. And finally, the board needs transparency. Trusting the CISO to report all systems green is not enough. Boards need to know at least the basics of security so they can understand how to prioritize investment. We need a common shared language. So for this reason, I'll close out this talk with a new frame for IT security that will help us have a better conversation with the board and the CEO about cybersecurity based on these 4 simple layers: governance, identity, visibility, and events. These layers are foundational to a new approach to governance that we call GovOps. And to do this, let's imagine that our enterprise is a boxer represented by Murderbot. And the embodiment of global hackers will be represented by Golem. And they're going to fight. And in order to win this fight, enterprises are going to need 4 tools. They're going to need brains to know how to fight. They're going to need their body to be in shape. They're going to need their eyes to see sharply. And finally, they're going to need muscles to move and strike. And the brain, of course, is the governance layer. And we already talked about the goals: risk management, accountability, and transparency. But we'll need systems in order to accomplish these goals. And we'll also need to show regulators that we're doing our job as governors. But remember, compliance only documents a subset of our governance requirements at a certain point in time. Compliance itself is not enough and should never be confused with governance. The next layer is identity. Enterprises have a lot of experience with human identity, and there are a lot of vendors and mature market categories. Of course, the software identity side is evolving. It may be a bit behind the human identity services, but it's catching up rapidly. But the most important point to remember is that identity is the key for accountability, not authorization. The next layer is the visibility layer. A boxer can't win if they can't see. And in this layer, we have our traditional log vendors like Splunk, and AI is helping us to detect threats. But a lot of investment and innovation is needed in this layer because right now most enterprises are flying almost blind. And finally, we have the event layer. This is the most immature enterprise layer. You can think of it like a boxer's muscle memory. Boxers don't think about how to throw an uppercut, for example. They've thrown a million during their training. So similarly, enterprises have playbooks on some of the things that can be anticipated, like an account takeover. For example, when an enterprise is alerted to an account takeover, they need to end all sessions and revoke all JWTs for the human and softwares involved. And this is why we may think about the landscape as a graph. The graph is all the things that we might anticipate might happen and the corresponding workflows to invoke. So coming back to the big picture, how do we have a conversation with the board about agentic security? First, we have to quantify our current risk exposures. Second, we can report on our progress, identifying agents and the various people, software, and third parties associated with them. Third, we can accurately report on the health of our security. And fourth, we can report on how prepared we are to deal with what's coming down the pike. For example, what to do about a rogue agent. And we need to do this in English in a way that presents the board with choices about where to invest. So that's just scratching the surface of GovOps really. But if you want to find out more, please join our LinkedIn group. And of course, if you'd like to experiment more with Cedar, check out this Janssen Project Cedar link. So with that, if you're watching this online, thank you very much.